Hello friends, welcome to this session of DSA. Here in this series of lectures we are going to study data structure and algorithm. As far as GATE is concerned, this is one of the most important and crucial subjects. You can expect minimum 15 to 20 marks question. So you can expect 15 to 20 marks from this particular subjects. Right. And this subject is a vast one, covers three topics or three different subjects. First one is programming fundamentals, and then we will be talking about data structure, and then we will be moving to algorithms. So if you put programming fundamentals, data structure and algorithm in at one place, it is going to fetch you around 15 to 20 marks in GATE exam. You see any previous year questions, you will find ample number of questions are asked from this particular subjects. Right. Now, even if you are in a final year and you are preparing for your placement or internship, this subject is going to be very crucial because you are going to be asked some fundamental questions on programmings, how to write the codes, various coding questions, and the ideas to how to write, what are the various ways we have to, in algorithms to solve a particular problems. And if we solve a problem using a particular method, how much time and how much space it requires. So first we have to design the algorithm, and then we have to analyze the performance of algorithms. So all these things we are going to cover in this particular subject. So before I start the actual subject, we need to study some basics of programming fundamentals. We are not going to repeat everything of programming fundamental, but I will be discussing all those things which are very crucial of programming fundamentals, and that are going to be useful in algorithm as well as in data structure. So first of all, I am listing out the topics which we require to study in programming fundamentals. So first thing, we will be talking about functions. So here the subject will go like this: programming fundamental. First we cover the basic of programming fundamentals, then we will be moving to data structure, component of data structure, and then we will be moving to the various concepts of algorithms. Right. So this is a combination of programming fundamentals, data structure and algorithms. So first we will be discussing some crucial and important concepts in programming fundamentals, and we will go one by one to discuss. First is, we need to discuss the basics of function and how function is going to be right, what would be the syntax, and it is a building block of our programming language C. So here we can use either the idea of C, programming language C, or C++ to discuss the various aspects of data structure and algorithms. So first we need to study about function, and then we will be talking about one beautiful application of function is recursion. So we will be covering recursion thereafter. Then we will be talking about array. Array is very interesting data structure, and there are many things to discuss in array. We are not going to start from we are going to start from the scratch, but we will move on to the top level where GATE is asking questions. You will be comfortably solving all these questions after these sessions, I am sure. So array, various types of array, how to calculate address in array, and then we'll mix array, and then after we can have a pointer. We will be having pointer, array, recursion, function, and then we can also talk about some concepts like dynamic memory allocation. Then after we can have a storage class. So after pointer we can have a storage class. Let's make a storage class. And all applications of pointer, all the questions related to storage class we are going to cover one by one. Right, and we can have dynamic memory allocation, right, and some other basic concepts we will be also discussing after, like what are the types of variable here, and like operators, few good operators from where get have asked questions like logical operators, various other operators, and questions on bitwise operators and questions on those. So let's start with function first. So in any programming language, function is going to be the building block for the programs. It's a, you can say, module. So if I have to design a complex problem, if you have to solve a problem which is large in nature, we can write many functions, and one function will do certain things. So if we combine many functions, the entire task can be simulated. So in C, function is a building block. In programming language C or in C++, function is also a building block, and there are some syntax for we need to follow certain guidelines for writing function. So we can define function as a set of statements which is intended to do some specific task. It may return something to you, it may not return something as per your requirement. You may pass some parameter to that, or you don't require to pass a parameter. So it is a set of instruction. We can define a set of instruction. We can define a function as a set of instructions to solve a particular problem, to solve a particular task. Set of instruction, either you can say set of statements to solve a particular task. Suppose if I have to find the largest number among three given numbers, so we can have a function for that. So we need to pass three numbers in input, which are the input to that function, and after doing certain computations we can return the largest number. So we can write a function for that. We can have a function for computing simple interest. It's the simplest example. From a given principal amount, the rate of interest and the duration in year, we can easily compute the simple interest and we can return back the right. Sometimes we don't need to return. If we have to say yes or no kind of thing, or some computation, something means we have to suppose give the increment to those employees who has served more than 100 customers. So it will be a certain kind of update statement in the database. So there we can write a function. So function may have return type, may not have return type. Function can accept input parameter, may not accept input parameter. Right. So whenever we talk about function, there are three things associated with a function. One is function declaration. The first thing is function declaration. Or you can call it as a prototype, function prototype. Function declaration or function prototype. This is the first thing. Second thing is function definition and or function call. You can say function call or function definition. And third thing is function call. Right. So there are three things associated with a function. If we have to write functions, we need to take care of these three things, three components of a function. Right. So function declaration or function prototype says just what is going to be the signature of the function. Means what would be the name of the function, and what is the return type of the function, and what are the parameters it is going to accept, and if it is going to accept, then what are the data types of parameter. Right. And sometimes we don't require to pass any parameter, and sometimes we don't require to return anything. Then in that case we can use void as a key. Void keyword is used if we don't need anything returned from the function and we don't require to pass any parameter to that function. So void can be used in that scenario. If we require to pass, then we need to pass the variable or what are the inputs we require to compute in the function. So for example, if I have to compute simple interest, right? So if I have to compute simple interest, so return type will be float, because simple interest, the value of simple interest may be in fraction. So float compute, the name of the function is compute simple interest. Compute simple interest. So here we need to pass three things, and they are of integer type. Right? They are of integer type. So here you can pass the variable also name, even if you don't pass, no problem, because by this statement the function or compiler will get to know that there is a function going to be used later on whose name is compute_si, and it is going to take 3 input parameters, all are of integer type, and it will return a float data item. So this is going to give you the signature. Either you can write int, comma int, comma int, or you can pass the name of the variable. Both will work, right? Next, then it is a function definition. Then it is a function definition. So here we have to define the body of the function, the purpose for which function is going to designed. That thing we will have to incorporate in the function definition. So the actual body of the function is going to be defined in this particular definition of the function. And then the function call. So when we have declared the function, when we have defined the function, then we can call this function as and when we require. Right. So function definition. So here function definition will be like this, that, or we can call function suppose in main. So we can have a main function. In C or in C++, a main is a driver function. The execution of program starts from main. So whatever you write, they should be controlled through main. So main is the driver function. Here execution of the program starts from the main only. So here we need to pass, we need to write a main function that there may be some other program functions, but we are going to take care about this particular function. So compute_si. So here we need to ask int p, r, p for principal, r for rate of interest, t for time. Right. Just I am making it simple. Right. And we will be also calling, we'll ask the user to enter printf. Just I am writing a very simple function to make you aware of it. Just it is a revision for all of you. So printf enter principal amount, right, rate of interest in rate of interest. Just it is going to give comment line kind of thing. User will get to know, get to aware that we have to, he or she has to enter the value of PRT, rate of interest, and time in year, and time. Right. Whenever you give this command, then a message will prompt on your screen after the successful compilation. Now here, again we need to ask users, because user has to enter. We want user to enter these things. Right. So for that we have a scanf. For that we use a scanf in C. So a scanf, and this is a PRT. They are of all are of integer type. So we will write %d. %d stands for access. %d we call it is access specifier, and D for integer, C for character, F for float, U for unsigned address. Right. So like that. So %d, %d, and wherever we are storing, we will store the value scan for this particular PRT. We have to store at their address. So in most of the programming language, or in all programming language, when we declare a variable, we need to have associated address with that. So if I say PRT, so PRT are the variable, and automatically they will be stored somewhere in the address, somewhere in the memory of the system. So here %p means it is whatever you will feed from the keyword, that will be stored at the address of p. So p value will be stored at its address. Similarly the r value, and similarly the t value. So here we have inserted. Now we need to, and we also know the return type of this function is float. So float and si, simple interest, this is the value, and we call si equal to this function we are calling compute underscore si PRT. Right. Compute underscore si, this is the name of the function PRT, and then we have to you have to just display the message. So this value of printf, PF means printf, just I am writing in short. So printf, the value of simple interest is value of si is %d, and SI. This leads to the end of main function. Now here we have done two things. We have all talked about the declaration, and this is a function call. Here we are calling the function. Because main is a driver function, you see, so we need to call the function. So just for simplicity, we have one function here in this whole program, and we are managing all these things through main, because in main is the driving function. Execution starts from main, so here main will control the entire activity. Now we need to define the function. We need to define the function. We need to define the function. So the function can be defined like this. So first we have written these things, and then we are defining the function. So adjust here. So float name of the function is SI. Now, so here we are going to accept three things: int A, int B, int C. Now there are two things. See here we passed PRT, so this is called actual parameter. So here we have received the value for principal amount, rate of interest, and time. So this is a formal actual parameter. Now we are passing this value to this function in the definition, and this is a call by value syntax. There are two syntax used in C for passing the parameter to a function. First is call by value, and second is call by reference. So here this is just a formal one, formal one, which is a call by value. So value of P will be passed to A. So this is P will be passed to this. So here the value of P will be coming. Here the value of Q is R is passed, and here the value of T is passed. This is called call by value syntax. Call by value parameter passing technique. This is the call by value parameter passing. So whatever we store, whatever we have inserted for P, for R and T, they will be copied to A, B, C respectively. Right. So here now even you can write PRT, no problem. But this PRT will have different address in memory, and this PRT will have different address in memory. In memory we can have two variables of same name, but they will be at the different address. So we have one PRT here, and we can have also another PRT, and we can make different name. So the main thing here is the value of P is passed to A, the value of R is passed to B, and the value of T is passed to C. And here we have to compute the simple interest, the value of simple interest. So float, because why we kept this as a float? Because the formula is principal amount into time into R by 100. So after dividing by 100, we may not get an integer. So for the better idea, for avoiding any truncation, we can use the float, and in that float value we can store the address. So SI. Here this SI and this SI will be stored at different address. They are not same, right? So here SI is equal to P into, here we don't have any P, here we have A. So A into B into C by 100, and then return SI. This is very simplest. This is easier example to understand a function, right? So here the body, when the last statement of the function executed, the return statement will be returned, and who will receive? So value will be received by this. So after SI, this SI will be received to this, and then the value of SI, this SI is corresponding to this SI, so value of SI is %D, and this SI will refer to this. So in this block, if we refer SI, it will refer to this SI. In this block, if we refer SI, this will refer to this SI. So such variable are called local variable. So a variable is local if it is locally used in that particular function or block. We will be talking about the types of variable when we will be discussing a storage class in detail there. Now, so this is the function declaration, this is the function call, and this is the function definition. So through these three components we can able to keep track of a function in programming language like C. Similar thing happen in C++, and just it will be a matter of syntax. Here if we have printf, so there we write C out, and here we have scanf, there we write C in, right? So almost things are similar in C and C++ with few changes. In these classes we are going to follow the rules of C, but if you are comfortable in C++, it is not a matter of big difference. Hardly 1, 2, 3 lines you have to change, and the things will be converted to C++, right? So one thing here we need to keep in mind that this is optional. Function declaration is optional if we have a defined function above to the call. Because see, if this is the first, this is the second thing, and this is the third thing. So if you write this is the first unit, if you write this is the second unit, and if you write this is the third unit. So why we need function declaration? Because at this particular time, compute underscore SI, the compiler will get confused. What means is not, compiler do not have any idea about this. So compute SI will correspond. Now in order to avoid any confusion to compiler, any compilation issues, this will refer to this particular declaration statement. This means compute SI is a function name, and it accepts 3 integer parameter and returns a float variable. So if we define function earlier to the call, here what we did, first we declare the function, then we call the function, and then we define the function. So in this manner we need all three things. But if we define function before the call, so if you keep this block above to this, so then this statement can be optional. Function declaration can be optional if function declaration is optional, right? Function declaration or prototype function prototype is optional if function is defined, if function definition is before, function call. Function definition is before the function call. Right. So if you define this function prior to this call, so if you make it 1 and then you make it 2, you don't require this statement. So this is one thing, because why at this particular point of time compiler has no any confusion, because compute SI, it has already get to know about compute SI. So there will be no issues. If this is the first and then this is second, we can avoid this. Otherwise we have to write the function prototype. Now here we need to discuss one more thing, that see here, this is the signature of the function. So if you miss, suppose this statement, if you miss this statement, right? So if you don't assign, so here it means a function is not going to do anything. Function is, if we are not assigning function to any variable, it means function is not going to return anything. Then it means the return type of function is void, but in signature we have made it float. So there will be a compilation error. So you have to be careful that whatever you have declared or whatever you have used in prototype, the same signature should follow. Here if you don't return anything, the function will be a compilation error, because we have made as a float data type, float as a return. So it means if we don't want to return anything, here we have to write void. So everything is in sync. So what we have prototype, same thing, we have followed the similar things in call, and the same thing have been done in function definition. So these are the small things you must be aware of it. Just it's a kind of revision for you all, right? Now, and time complexity of function. Suppose if we have to compute a time complexity of function, so here we have to count the frequency count of all the statements in all the functions. So these things we will be talking about when we have the idea of when we will be talking how to compute time complexity in a space in the algorithms, right? Now, so again one more thing. Program execution starts from main. Program execution always starts from main, and program statements are executed sequentially. So statements are executed sequentially. So this will be the first statement, this is the second statement, printf is the third statement, scanf is fourth statement, and this function call is the fifth, and this is the sixth statement. So we will be 1, 2, 3, 4, 5, right? But if there is a function call, then the part below to that function call will get skipped. First control will go to the body of the function. So if I say this is one statement, this is second, this is third, this is fourth, this is fifth, this is sixth. So fifth statement has a function call. So the sequential execution will stop. Now control will go to the definition of the function. So whenever there is a function call, we have to first go to the body of the function. You have to execute the function, and then when the last statement of the function gets executed, then again you have to come back, and then you can execute the sixth statement. So this is the common thing, you are aware of it. Just for your revision, I said that if there is a function call in a body of the execution of a program, the statement below to it will get skipped first. The control will go to that body of the function. When the function computed completely, it will come back to the calling function. So here main is calling function and compute SI is called function, because main is calling whom? Main is calling to compute underscore SI function. So we call main as a calling function, and who is going to be called? It's a compute SI function is going to be called, so they are called, it is called called function. So we have calling called mechanism kind of thing in this particular programming language, right? So now one useful application of function is recursion, and recursion is very, very popular tool, a popular tool to solve many complex problems. So if we are going to discuss in later on in data structure some application of tree, then there you will find recursion is very handy tool. With the help of recursion, you can simplify a problem in a logical manner. And there are many applications of recursion. Is that Tower of Fano is an application of recursion, and then function, the manner in which function is called, they follow the idea of recursion. Right. So with the help of recursion, we can solve many complex problems. So first, now let's study the function recursion, how recursion works. Right. So application of function is recursion. First application of function is recursion, and there are many good questions Gate has asked based on recursions. So recursion is a very handy tool when we have to solve a complex problem, and the problem will call a smaller problem to solve the final value, to get the result of the final question. For example, if you ask me that, or if I ask you what is the value of 100 factorial, so if I ask you, tell me the value of 100 factorial. Just I am giving a common example for recursion. Can you say the answer? It is very difficult to say the answers. Calculator may also fail to store the result of 100 factorial. Normal calculator may fail. So if you are a smart guy, you should ask me, give me the value of 99 factorial, and I will give you the value of 100 factorial. And this is the recursion. This is the only recursion. So a large problem cannot be solved in one go. So a large problem can call a smaller problem of the similar size, with less of the similar nature of less size. So if you are a smart one, you will ask me, just give me the value of 99 factorial, and I will give you the value of 100 factorial. So answer to this question depends on answer to this question. And as compared to the value of 100 factorial, the value of 99 factorial is a smaller problem. Again, this problem is still large enough. We can't solve. We don't know the answer. So again, it will continue in this manner, that 99 factorial you can only answer if you have the value of 98 factorial. Right. So in this way, this decomposition of the problem, this is what 100 is calling 99 factorial, 99 is calling 98 factorial. So this mechanism is called the decomposition of the problem. This is a decomposition of problem into smaller problems. So 98 factorial we're going to call 97 factorial, and so on. And what we know, we only know the value of 0 factorial is 1 and the value of factorial 1 is 1. We only know what we know. So the value of 0 factorial is 1 and the value of 1 factorial is 1. Other than this, we don't know anything. This is called base condition. So in case of recursion, the size of input where you know the answer, the size of input where you know the answer is called base case. Here what we know, we only know the value of 0 factorial is 0 and the value of 1 factorial is 1. Rest things we don't know. So this decomposition continues till we reach either of this where we know the answer. So in this manner we'll reach like 3 into 2 factorial, and then we'll reach like 2 into 1. 2 factorial we'll call 1 factorial, and then we know this answer is 1. So this is 2. So value of 2 factorial is 2. Now 3 into 2 will be 6, and so on till we reach to this point. So the value of 1 factorial is 1. So 2 factorial value we got 2. Now this is the call of what? 4 into 3 factorial kind of thing. So 3 factorial is calling 3 into 2 factorial. So 6, 3 into 2 will be the value of 3 factorial. With this multiply 4, it is 24. It is going to be the value of whom? 4 factorial. So we have first 100 is calling 99, 99 is calling 98, and till this way decomposition continues till we reach the base case. So this, from top to down we decompose the problem. From top to down we decompose the problem, and this decomposition continues till we reach a base case situation. Means base case means a scenario where we know the answer or input data for whom answer is readily available. And then this way top to down is decomposition and bottom to top is building the solution, solution building. So first decomposition will continue, and then when we stop, then from bottom to top where we will have a solution. This is the idea of recursion. Right. Now here if we have to write a program for recursion, we can write the program in 3-4 lines, but that will give you a logical solution. That will give you a simplifying the problem. With the help of recursion you can simplify a complex problem and you can give a logical answer in a correct way. But as far as time and space is concerned, function recursion may not be the ideal one, may not be the efficient one. So we will be talking about the time and space complexity more and more in coming classes, but here I will be also talking about how we can solve this particular problem without using recursion. So if we have a problem and you can solve it using recursion, and you are also going to solve it without using recursion, so you can compare which one is a better one, right? Many times or almost all the times the recursion takes usually more or equal time than non-recursive method. Again I am repeating, the recursion takes more or equal time than any other method. So we call we cannot say the recursion is efficient method as far as time and space is concerned, but it is going to give you a powerful tool to solve many complex problems in either equal time or certainly slightly more time. If you are not worried about time, you have ample time, and you want to crack a complex problem, then recursion is a very handy tool. Suppose if you have to call a sort function, you want to sort numbers, so you can use the idea of recursion. Means you will, if you have to sort n numbers, you may sort first n-1 numbers, or you may sort first n by 2 numbers, then n by 2 numbers, and solution to n by 2 will combine to put the solution of final answer. So in sorting, if you have to use recursion to solve a sorting problem, what would be the base case? So base case will be if we have many numbers to sort. This is the main, here we have many numbers, so we have to decompose. So this decomposition continues till we reach the base case where we have only one element in the array. So if we have only one element in the array, by default element is sorted. So if you recall the idea of merge sort, first the division. So division continues till we reach a situation where the first index and last index is same. First index and last, the beginning and last of the array is same. So beginning and last of the array is same means array has only one element. So when we got only one element in the sub array, we stop, and from that point of time, after that onwards, we will build the solution. So many merge sort many sorting algorithm can be written using the idea of recursion. Merge sort is one example, quick sort is another example. Similarly, we will be talking about many other sorting algorithm in coming classes. Right. So how to write the pseudocode for first? So for finding the factorial, this is called factorial of a number. So first recursion. So a function calls itself again and again. A function calls itself with a smaller data size. A function calls itself with a smaller data size. You will never find fn is calling fn to n. This will never happen. So whenever we have to call n, fn will always call anything less than n. This is recursion. So you will never face a situation where a function is calling to a larger problem of the similar size. No, this will never happen in recursion. A function always calls similar function with a strictly less size. Right. A function calls itself with a smaller data size. So here, and this is a recursion is a powerful tool. Recursion is a powerful tool to solve a complex problem with the help of a smaller problem of same nature. Right. A recursion is a powerful tool to solve a complex problem with the help of a small problem of the same nature. Right. Now, so first we can have a function for this factorial program, factorial number, and then we'll compare the time and space taken by recursive method and time and space will be taken by non-recursive method, and then we'll come up with one conclusion. Right. And see, recursion can be of two types. One is direct and one is indirect. Mostly we are dealing with direct recursion. So direct recursion means A is calling A with a smaller data size. So if we have n, so here an kind of thing. This is called direct. This is a function is calling itself with a smaller data size. So data set size is less than n. Another way of recursion is A is calling B, and obviously data size will be small, and B is calling A. This is called indirect recursion. Mostly we deal with direct recursion. You will rarely find an example of indirect recursion, and this is called indirect recursion. Means where A is calling B and B is finally calling A, and in each case after this call, A calling to B and this B calls to A, so size of this will be more than the size of this. So size will strictly decrease. If size won't decrease, function will not stop. It will go on execution of and go on executing, and your memory will system will hang and you will run out of memory. So that's why the reason is every time size must be called. If we don't have a lesser size, function will never end and it will exhaust your memory. That is the idea. Right. So here I wrote a function calls itself with a smaller size. Calls means maybe direct call or maybe indirect call, like this. A calls to B and B calls to A, and here A calls to A. So there may be direct call or maybe indirect call. Right. Alright. Now next here is, so if you have to write a program for finding factorial of a number using the idea of recursion. So let's go. So just I am writing the function definition. Other things you can easily write, like function prototype and function call. So first I am writing function definition, main thing. So int, name of the function is factorial. Why I wrote int? Because we are going to return the value of factorial of a number, and I assume int will, whatever you return, that will be capable, integer is capable of storing that. If integer is not capable of storing that, then you have to go with some other float or double kind of thing, right? So or long int, if because we don't know what is going to be the answer, because factorial of a number can have a high value. So for that we may integer limit may cross. So I assume whatever the answer we have, that will be taken care by the size of integer. If we have a larger size, we should write long int and others, right? So here we have to pass input int n, right? And what is the base case? So in every recursive program there must be a base case. In every recursive program there must be a base case. Without base case you cannot write a recursion, because your recursion will never stop. So base case is must, right? And here the base case is if n equal to 1, 0, or n equal to 1. What you return? Return 1. Right? Else, what we need to return? Else return n into same function will call. We have to call the same function with a smaller input size, factorial n minus n. So it's hardly 2 lines of code, this if and this else part. Hardly 2 lines of code, and this is going to compute you the factorial of a number. So let's have example. Suppose if you call factorial 10, so what it is going to call you? This condition is not satisfied, right? So we have a main above to it we have a main, because main will control the execution. So we understood a main is there in a picture. So this is going to call 10 into factorial of 9, right? Now still this control will come again to this function. Again this base case is not satisfied, so again it will call similar 9 into factorial 8 n minus 1. Again it will control. So again there will be a new function call with different input size. So this will continues like 2 into factorial 1. Right. 2 into factorial 1. So again this factorial 1 will call to this function. There will be a separate call, and when factorial call is 1 is there, the return 1. So here this 2 into 1, this is the answer of whom? 3 into factorial 2. So this value will be 2, and this 2 will be passed to this, and so on, and so on. So if you see what is happening here, a function, whenever we call a function frame gets created. So first function frame was of whom? The first function frame was of main. Main is calling all the functions, and what main is doing? Main is calling factorial 10 function. I write 10, f for factorial. For simplicity, I say this is f. So f10 will call what? F10 is calling f9. What? This way a stack function frame creates. And f9 is calling what? f8. And so on. So see, this is a function frame. It's created in the manner a stack works. Last in, first out. So the below is main. After that it is f10, f9, f8, and in this way what will happen? We will continue till we reach where answer is available to you. And where the answer is available to you? This, at this place. So this way we will continue till we go f1. And when f1 we know the answer 1, then function frame get destroyed. And f1 is called where? In f2. So with the help of value of f1 we get to know the value of f2, so f2 will get destroyed, and finally all will get destroyed. So first we create the function frame, right, and from main to f10 to f9 to f8 till f1, and when we destroy the frame, like f1 first will be destroyed, f2 will be destroyed, function frame of f2 will be destroyed, then so and function frame of f8, then function frame of f9, and function frame of f10, and then finally function frame of main will get destroyed. So whenever we handle function, many function frames are created in the memory. Many function frames, and it depends based number size of the input. So here in this case, how many function frame will be created? 100. If I have n, so n function frame will be created for this particular function, and for main one more function frame. And see, if we have not written this program properly, you have some error in your code, and especially if you have not handled the base case properly, then function frame will go on creating, and your system will hang and you will run out of memory. So whenever you are dealing with function recursion, you have to take care of the base case. It is a situation where function call stops and building of solution starts. So if a base case is not written properly, your system will hang and you have to forcefully stop the program, right? So this is the thing you have to take care in recursion. Whenever you are handling recursion, be cautious about base case. So I am going to write few points about the property of recursion, and we'll talk about other things. So first of all, creation of function frame is nature of recursion. This is the first property. Creation of function frame is the nature of recursion. Creation of function frame is the nature of the recursion. Right, this is the first point. Second point, because we are getting many function frames and system may run out of memory, or system may hang if base case is not handled properly. So system may run out of memory, or it may hang. System may run out of memory if base case is not handled properly. Base case means the situation where the function call stops, where the call to function stops, right? And recursion is usually not efficient. Is not efficient in terms of memory and space, in terms of time and space. But it is a very powerful tool to solve many complex. So it doesn't mean we will not use recursion. It is not efficient, but it will be equally good or it will take more time, right? But it is going to help you a lot. It is going to give you a logical simplification of the problem, means in which manner you can simplify the problem, right? So we'll have an example for this. So here we have a recursion function for finding factorial, and we can also have a non-recursive method, and then we'll compare how much. See, what is the time, what is the space complexity of this program? So as of now, just you only think a space complexity of program is nothing but how much variable you require in the program, how much unit of space you require. That is a space complexity. Time means how much time you require, and what would be unit for the time. So it will be frequency count, means based on the input size. So we will be talking about the time complexity and a space complexity in detail. But here, as I wrote, recursion is not efficient in terms of space and time. So for that I am giving you the idea how much time, how much space it is taking. So if we pass n here, if we pass n, so how many function frames are created? N function frames are created. So for every time we have to provide a space for storing that variable of n. So suppose f10 is calling f9. So we need a space for 10, which is pass, a space for 10 and a space for 9. So we need n variable space. So whenever we call this function, for every time a function is called, we need a space to allocate to store the call by variable, which is called by value. So for this particular n, we need another n. So if 10 is now storing n, now we need another n to store the new value of n, which is now 9. So a space complexity of this program is, if I say how many variables we require to execute the program, here we require n variables, because n times we need to pass this value using call by value mechanism. But if we have non-recursive method for factorial, we know easy way of doing this program without using recursion. Just we can have a simple loop. So another way is factorial 2. So here right. So another way is that int factorial, right? Here int n. So here we can have a simple loop. So int I, right? So for, and here we have to store factorial, value of factorial, which is I assume 1 base case. So we need to have a loop for I equal to n, I greater than equal to 1, I minus, and fact equal to fact into I, and finally return fact. So if you see, we have used a variable where we are storing the result. So I star, suppose if you pass 10, so I value will be 10. So what we are doing? So fact equal to fact into I. So fact is 1. Why we use 1 in the base in the declaration? Because if you use 0, so 0 multiplied by anything will be 0. So whenever we have to multiply continuously, we should take the declaration we have to initialize with 1. If you have to sum it, we should initialize with 0. Right. So this is a common programming idea, that I equal to n. So I is 10 and fact equal to fact into 10. So first time fact will be 10. Now I is greater than equal to 1, still condition is 2, so fact equal to fact into I. So I equal to 9. Similarly it will continue till we have 1. So you will get the answer here, and you are also going to get the answer here. So here what is the space complexity? Irrespective of this n, whether this n is 100 or this n is 200 or this n is 300, you need only 2 variables to store. You need only 2 variables, I and fact, irrespective of this size of n. Here, if n is 10, so you need 10 variable space for storing n every time. Here you require only 2 variables. So here a space complexity is constant, is order of 1, means constant. Right, and here a space complexity is order of n. See, if you are not comfortable with the space complexity, just assume how much unit of variable you require in terms of input size. So here, whatever is the n, may it be 100, may it be 1000, may it be 10,000, we only require 2 variables to run this loop. Here if we have 100 value, so we need 100 times variables. So as far as space complexity is concerned, this one is a costly one. This one is costly as compared to non-recursive. So this program is just to prove that recursion may not be efficient. Recursion may not be efficient, right?